So in this video, I'm going to talk about congruent theorems for congruent figures. Start with the definition. Congruence: two figures are congruent if and only if corresponding angles are congruent and corresponding sides are congruent. Alright, just take a second to notice that this is a lot like our definition of similarity. Figures are similar when corresponding angles are congruent and corresponding sides are proportional. In this case, congruence is really kind of a special case of similarity. It's when the corresponding sides are not just proportional, but they're actually congruent. They're the same size. So all the angles are the same size, all the sides are the same size. Now, as with similarity, there's some shortcuts we can use, some theorems that we can use to get to show that two figures are congruent without having to show all the angles are congruent, all the sides are congruent. Okay, so we'll just be talking about triangles now. So first one is called side, side, side. Now, there's a side, side, side similarity theorem. We've already done that. Now we're going to talk about side, side, side congruence. And again, this is just for triangles. Side, side, side says if the corresponding sides of triangle ABC and triangle DEF are congruent, then triangle ABC is congruent to triangle DEF. So what's that saying? That's saying, like, if, say, AB and DE are congruent, so, maybe we have this written in the diagram, BC and EF, BC, EF, AC, FD. If we have all of those, right, we have AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, then we can say, okay, therefore, triangle ABC is congruent to triangle DEF by SSS congruence. Okay? So, again, just like with similarity, it turns out that we don't need to know that all the sides and all the angles are congruent. It's enough to know that all the sides are congruent. Right, so that's side, side, side. Next up, side, angle, side. Side, angle, side says if two pairs of corresponding sides are congruent and included angles are congruent. Sorry, I'm trying to fit this all in. Then the two triangles, ABC and DEF, are congruent. So what does that mean? Remember again, included angle, we have to remember this thing. Included angle means the angle between the two sides that we're talking about. So here's an example. If I know that BC is 5 and EF is 5, I know AC is 10 and FD is 10, and I know that the included angle between the two, that these two angles are congruent. That's going to be enough for me to say that these two triangles are congruent by SAS. So I have a side, angle, side. I've got BC is congruent to EF, right? Both 5. I've got my two angles. Angle C is congruent to angle F. And I've got my my other side, AC, is congruent to FD. Alright, so I've got side, angle, side, so therefore triangle ABC is congruent to triangle DEF by SAS. Oops, I didn't have that. sorry, there it is. Okay. Next theorem. This is the last one we talked about in this video. Angle side angle congruence. This is different. Now the other two we saw, we had similarity theorems that were like this. We don't have a similarity theorem for angle side angle. So this is angle side angle congruence. If corresponding angles are congruent and included sides are congruent, then our two triangles ABC, DEF are going to be congruent. So I've got, if I know, for instance, that angle A is congruent to angle D, and I know that angle B is congruent to angle E, and I've got this side in between, the included side. That's going to be, again, just like included angle. Included side is going to be the side between the two angles. So in this case, AB, in this case, ED. Now, based on this, right, I've got angle A is congruent to angle D. I've got AB is congruent to DE. And I've got angle B is congruent to angle E. So I have angle, side, angle. In that order, this is going to be important later on, right? I've got angle, side, angle, angle, side, angle. Therefore, triangle ABC is congruent to triangle DEF by ASA. All right? So those are my first three theorems. SSS, SAS, and ASA.